Hey, welcome back, students. So let's continue our review here with 3.7. We're talking about solutions and mixtures. And a couple of items that you need to know right off the top here is whenever we talk about solutions for us is going to be when you have some kind of substance, let's call it the solute, and this is going to be dissolved in some solvent. And so that's the key part here. So it's dissolved in that. And essentially when we do this, the solute can either be a solid form, it could be a liquid form, it could be a gas form. But the main thing here is that you've got a mixture of these phases, and one of them, the solvent, is the one that's going to be doing the dissolving of the other one being the solute. And so there's a couple of items that you do need to be aware of. Among those items are things like intermolecular force. So you need to be aware of that. That means the attractions that are occurring between either the solute with another solid molecule, a solvent with another solvent molecule, or then the cross between a solute and a solvent molecule. If those attractions are occurring, you need to pay attention to those. Some of those attractions are better than others, but for the most part, intermolecular force is an important factor that you should consider. Another factor that we need to consider here in this regard is going to be the effect of temperature. And so temperature is going to have a very direct impact. We already know that as temperature increases, this is going to lead to a very direct increase in the kinetic energy. And so kinetic energy then might be enough to overcome some of the attractive forces that are occurring between some of the molecules. And so putting those into perspective are always important. And then one of the other items that we need to be aware of is this item known as concentration. I'll represent it like this. However, concentration is literally going to be the amount of moles over a given volume of a solvent. And so you want to make sure that you are aware of that. Now, in this regard, we need to make sure that this discussion with the concentration is explained a little bit further. So let's kind of look at that now. The concentration can be one of two types. And so the first type is something known as a molal concentration. And so I'll put that in brackets to represent that. And the molal concentration is the number of moles of a solute or a substance that's going to be dissolved in a very specific mass of the solvent. It's in kilograms. Now, we're not going to be looking at this one here for our exam. In fact, the AP exam is not going to ask you about that, but it's important that we at least talk about it so you know what it is. The other concentration form that we will actually look at is going to be the one called molarity. And molarity here is going to be the number of moles of the solute, but here it's going to be over a given volume of solvent, which is what I had already shared before right up here at the very top. That's the version that we're going to use. And so just to kind of put this here, we will look at this, but we will not consider the one on the right-hand side there. Now, a piece that you should be aware of is what happens here with solute and solvent. And so let me move some of this stuff over here to the right-hand side to make some room. And so let's talk a little bit about the solute. The solute here, just to make sure we explain it, the solute is what's going to get dissolved. This is the compound that gets dissolved. And we'll put that there, it's dissolved. And the solute, in contrast, or excuse me, the solvent, this is the actual thing that actually does the dissolving. So this is the one that dissolves, the solute. And so the solid usually goes the solvent. And when it does that, there's some interactions that occur, or some interactions that you need to be aware of. So when you actually mix these two together, these two together here are going to lead to something known as a solution. Now, the solutions that we're going to be considering here in our discussion, or at least the ones that are going to be considered for the exam, these are going to be homogeneous solutions. Largely because when we mix a solid with a solvent, we're mixing two things together. So in reality, this is a mixture. But in the context that we're going to be looking at here, we're going to be considering kind of like a solution involving two of the liquids or two of the substances in the liquid form. And in that regard, the mixture that we're going to be looking at in specific is a homogeneous mixture. Now, you could have a heterogeneous mixture. However, we're going to focus on the homogeneous mixtures here for this exam. One of the main reasons, largely, the homogeneous mixture is going to be the mixture that has uniform composition. That's one of the main hallmarks of this one here. Okay, so we'll put it like that. It's important then to tell you a little bit about the solvents. The solvent, the most common one that we're going to use in our discussion here, the most common here is going to be water. Now, I would spend a little bit of time looking at the structure of water, but remember briefly here, water is a structure where the oxygens and the hydrogens that it's bound to are at a bent structure, and we've got lone pairs here that essentially are going to be pushing those hydrogens down or pushing the cloud down to give the molecule a bent shape. As a result of the benting, we do know that there is a bond arrow that would go up this way, largely because the electronegativity of oxygen is pulling the electrons. And so we can see that there's actually a break in this, giving the top part of the structure a negative side and the positive side down below with the hydrogens. And so this particular instance here is what is known as the molecule of water being polar, because you have two sides. The top part is negative, the bottom side is positive, and because of that you've got two separate poles. That's the nature of the polar scenario. Now, this is important because when we actually go through and create the solutions here in this section and in later sections, water then has to be drawn properly within the context of the solution, especially in the next section when we talk about particulate diagrams. You definitely need to position the water correctly against an ion that is in solution so that the water is positioned either with the negative part facing the ion or the positive part facing the ion. And so that's something that you really do need to consider here as you go through. But nonetheless, though, the main thing that we've got to figure out here in all of this is that concentration. So having said that, let's kind of look at that concept now. Let me move some of the stuff over here from this side. Let's move it over to the right. All right, so since the main thing that we're going to do here is create a solution, let's kind of explore how we do that. In order to create a solution, what you're going to need is obviously some kind of container. The most common container is a beaker, but you can also use a volumetric flask. And so I'll do my best here to draw the volumetric flask. It looks something like this. And the volumetric flask has a line at the top. That line there is called the fill line. And so we'll do that. Now the graduated cylinder, or rather here the beaker will have various graduations that you want to look at, and they would essentially serve as the same kind of deal on the volumetric side. But the volumetric flask is the more accurate of the two. And so what you'll do here is that you want to know how much of a substance you're going to add. So if we're trying to figure out a substance, let's say that we're going to represent the substance here in red. And so we'll talk about here the solute. Typically what we're going to be concerned with is how much of the solute are we going to put inside here so that we can then add a certain volume to it. Now, if you want to prepare a given concentration, typically the equation that you want to use from before, you would have to use the big M for the molar concentration. And this is going to be equal to the number of moles of the solute. And this is going to be mixed in a certain volume of solution. And this volume is typically going to be in liters. And so you want to make sure that you are able to mix things accordingly. So once we actually get the amount of solute that we want, we can actually just put it inside here. And so we would get this, put it inside. And so inside here, you would have your solute in here. You would also, if you put it inside the volumetric flask, you would have that in there like so. And this amount here corresponds to a very specific mass. Now, keep in mind that we're having moles in the numerator here. We need to make sure that we also look at the other version of the same equation, which means that if I take this moles of solute, that's because I'm able to take a certain mass of the solute given by a proportion to its molar mass of that same solute, and put that in parentheses in the numerator. And then down below, we would also have the volume, just like before, in liters. So it's important for us to make sure that if we're using this version of the same equation, we want to just get the volume, or excuse me, the number of moles, and divide it by the volume. That should easily give you the answer that you're looking for. Now, if you're asked to prepare a solution, typically what will be given to you is going to be given the identity of the substance or the identity of the solute, And then you should be able to figure out the molar mass of that solid by looking it up online. Or rather, by looking it up on the periodic table, you should be able to figure out the molar mass of that particular solid. With that information in hand, if they give you the certain mass, just plug the mass up here in the numerator. In the denominator, you would have to figure out the molar mass if it's not provided. This will give you the number of moles at the very top. And then if the volume is provided, simply provide it here. But normally the volume will be provided for you. The mass will be provided. You might need to figure out the molar mass, and then that will give you an opportunity to figure out the concentration. So let's go ahead and look at an example. Let me move some of this stuff up here, make a little bit of room for ourselves. And we're going to take an example. And let's say here that if we had a 200 milliliter volumetric flask is used to prepare, and let's say a 3 molar solution of, and let's be kind of simple here, let's say a molar solution of lithium hydroxide, LiOH. The question usually asks you, how much am I going to need? How much LiOH in grams is needed to make the solution? And so ideally what you want to do is begin with the information. So notice here we've got 3 molar. So what I will do here is I'm going to go ahead and just underline that because that's a given for us. The other item is that we're also provided this information here, 200 milliliter volumetric flask. So that means we're going to use this one over here. So we got to figure out how much of the material are we going to place in here in the volumetric flask. But we are provided the 200 milliliters that is given to us. And what we want to know is, here's the keyword, how much, and in grams. So for us, it's beneficial and convenient for us to go ahead and write some of this equation down. How are we going to do that? Well, the equation is, as we've used in the past already, we're going to use this equation here. And so what I'll do here is I'm just going to go ahead and take this equation and rewrite it down here, just so we can start putting our math together here. So we'll have big M is equal to the moles over volume, but I'm going to use the version on over here on the right-hand side. I'm going to use mass over molar mass. And so that'll give me the mass over molar mass, and this is going to be over the given volume. So I'll just write it like that. Now, since I'm trying to figure out the mass, what I want to go ahead and do is just derive for the mass. Now, I'm not going to show you the overall math, but clearly you can see here, if I take the volume, multiply by the molarity or the concentration, and then multiply by the molar mass, that should allow me to get the mass isolated by itself. So the end result of all of that work, though, if we do it, is going to end up with us having the formula concentration times the molar mass times the volume is going to be equal to the mass that we're after. And so if we put the numbers in there where they go, that should give us the following. So I'm just going to go ahead and put mass over here at the very beginning, and I'll just fill in the numbers here and we'll continue from there. So let's see here. So I'm going to go ahead and put here for the concentration, that'll be 3 moles per liter. Multiply that by the molar mass. That value should be 23.95 grams per mole. And then I'm going to multiply that by the volume. In this particular case, since we've got 200 milliliters, we want to prepare that. So we're going to fill it up to the line for 200 milliliters, and that will give me a liter value of 0.2 liters. So let's cancel what we can cancel out. Liters cancels with liters, moles cancel with moles, and so that leaves the unit of mass in grams. And so let's go ahead and calculate that all the way through, and we should have the answer here at the very end. So what we'll need to grab here for ourselves, we're going to need to go and grab 14.37 grams of LiOH. We'll take that mass, and we're going to go ahead and add that here. That's how much we should grab, and then enter into the volumetric flask. Then you would fill it up to the fill line, put the stopper on top, invert, agitate, mix it thoroughly, and then the solution that's inside will have the concentration of 3 molar. Okay? So you should be very comfortable and familiar in doing that. Now, another thing that you might be asked to do here is to represent this in terms of a particulate diagram. So you got to make sure you know how to do that. Spend a little bit of time with that, and actually that is actually the focus of the next section. And so we'll go ahead and do that. But before we go, you should be very familiar with the ratios that exist between the compound and the components of that compound. So for example, LiOH is the one that we just used. Let me make some space here. Let's make some of this over here. And let's just write this stuff down here at the bottom. So LiOH, if we look at this, the LiOH is actually composed of the following. So we know that we're going to have a positive side for the cation. We know we're going to have a negative side over here for the anion. But there's only one copy of each. We know that there's a coefficient at the very beginning, so that means here, for every one copy of the compound, this is going to be proportional to one copy of the ion Li plus, and we know that we're going to have one copy of the ion OH minus. And so the ratio here between them is actually 1 to 1 for the lithium and the compound, and a 1-to-1 ratio here for the hydroxide and the compound. So knowing how this works is really important for us, especially when we're trying to figure out calculations with charges, the concentration of ions. Here in this particular case, if we're after the concentration, say, of the hydroxide, all we really need to do is to find out the concentration of the lithium hydroxide. In this case, we know it's 3 molar. So what we would do here is, if we know that the concentration of the entire thing here, if this entire thing is equal to a 3 molar concentration, that means that the concentration for the lithium is also going to be equal to 3 molar, and the concentration for the hydroxide is also going to be 3 molar, largely because of the ratio between the compound and the individual ions. It's 1 to 1. So those are some of the big things to focus on here in this particular unit. So just make sure you spend a significant amount of time looking at over all of that. If you have any questions, obviously see me in class. But with that, we'll cut it here, and we'll move on here in the next video. We'll go to a review of 3.8, and we'll see you then.